Hello everyone, my name is Julian and I am a developer for the Comprion USIM USAT test designer. Today I want to show you how you can write your own custom tests using the code editor of your choice. Don't worry, we won't have to write any clever code today. Rather, we will reuse and adapt the already existing sample test cases.
As a preparation, I've already installed the test designer using the setup file. And now we open a File Explorer window to the sample test case directory. We have a sample test case directory here and a Visual Studio solution. This is the one we are using, and open it up, this SLN file, with a Visual Studio. We could use any other code as well, code editor. Here is the sample test case proactive command that I want to use as a base. We copy all the code and then create a new test case. We call it proactive command and add the suffix of the intent that we have, the display text. Now paste everything and now modify the class name to reflect our intent of the display text in the class name and in the reference for the documentation, as well as in the constructor. Next step, we have a look at how we can add the constant strings that we need. One is the one of the command name, which will be display text, and the other of the content that we want to project. So this is the text that will appear on the display of the device. We just use foobar because this is the default for developer tests. Right, next up we modify the execute method of the existing sample test case, and instead we write our own execute content. This is simple. Using IntelliSense we can just write a new method name that doesn't exist, and then using the quick actions and refactoring we just derive a new private method of it. By default this method does nothing except throw an exception. This is what we are going to fill with some logic. We add the display text command here, and then we create another method that doesn't exist yet, create display text, and we add a parameter of byte value 001 and the text to display variable that we have defined as a constant above. That's pretty much it. And then we derive this method as well. Okay, now we have a method that is going to return an object. We don't want to return an object, but rather we want to return a proactive command. And for this command type we are going to use the iProactive command. Then we throw out the default exception and define a list of the actions that we need to return here. It's a comprehension TSV data object. Yeah, this is what the compiler doesn't like. And now we use an implicit collection initializer. Data object factory, we start with the command details and then we add the command number. Oh, we have to add the command number in the parameter of the method. This is going to be a byte, so we modify it from an integer to byte. Byte command number. And then we also add the type of command that we need. It's going to be a display text. Also, we don't need any compression required here. Note I end with a comma because it's a collection. Next, we add from the data object factory the device identity that we need, and it's going to be from UICC to terminal. Note with code completion we are pretty fast here. The method signature always says what we are going to need. Finally, we add the text string, which is the text to display in the method parameter. We add it here, and an encoding is also required. See the signature, we also don't need any comprehension. Note, we end with a comma, and now we need to create a proactive command from it using the proactive command factory. We are going to create a command of the type that we need. It's an iDisplayText. And this is what we are going to give to the card simulation service when running the create proactive command method. Just put the constant value of the sample text foobar inside here. Save it. Verify it's working fine. Okay. We also now change a bit of the display text method. This is what we are going to write out here. First of all in the verdict, and second of all in the output during the test execution. Fine. We build it again. We built it. We don't need this artifact. We just want to make sure that it compiles. Right. Next up, let's open the device test center. We're going to create a new test plan, which is pretty much default. We're going to use sample test here and select the USIM user test designer here. We are going to rename one of these as a display text so we can distinguish it from others. And as properties, we are going to change the scripted CS file name from the default simulation to the one that we have just created, the proactive command display text. Close and don't forget to save it. And then we can start the test case. It starts up, and we can see after the initialization it says, okay, verdict is send proactive command display text, the one that we just had. Now we are going to start the mobile. I have one connected to my proof 2 here. And since it's a slow one, we are going to have to wait for a bit longer. And once the mobile has booted up, I can press the continue button in the center to send the proactive command to the device. But now we can see, okay, ISO activation is detected, power on is received, and card simulation is now being pulled from the device. Still, we are going to take a bit of time. And now we can see, okay, the status APDU was seen, the mobile is kinda bored right now. Okay, these are good conditions. Let's send the signal and wait a bit. Okay, the proactive command was sent, and then we wait a bit until it is properly received by the device and the display text is performed. We're going to see it at both at the device level and in the info view as well. Okay, there we can see it in the bottom. The proactive command was detected. Okay, then we can finalize the test case and close existing windows. We're going to look at the monitoring. We don't need the physical layer or the either protocol layer. I just want to show you in the bottom the proactive command area in the bottom. There it is. Fetch display text, and we can see, okay, the text string to display was sample text foobar hash. Right. This is the simplest way to run your own custom test case, and you can execute it yourself in the device test center with the test case designer. Finally, I want to show you the API designer documentation, where we can have a look how the specification of the API call of the iDisplayText method is working. We are going to add the filter iDisplayText. There it is. Here. You can see the API documentation in your web browser once you start it from the start menu. We can also see the other proactive commands. They are also listed in this reference, what parameters they need, and so on. Now you can go and create your own test scenarios without having to manually place the bytes where you need them. Of course, you can do this yourself as well, if you know the exact byte specification that you need. Goodbye.